Welcome to How to Run a Regression from Raw Data, Part 1. We begin from the home screen by clicking on Edit List. This is where we will go to enter the data from the problem. Generally, we will enter all the x's into list 1 and all the y's into list 2. So let me enter some numbers. I found a problem. I'm going to enter the numbers 1 through 6 into list 1. And then in list 2, I will enter the y values. 1, 5, 10, 20, 25, 40. After I've entered all my x's into list 1 and all my y's into list 2, I want to click on the menu button and go up to the regressions option. When I press regressions, you'll see it'll bring me to the full regressions menu with many options. In part 1, I like to cover just these first two, linear and quadratic. So let me click on linear regression at the top, and this brings me to the linear regression screen. You'll notice the only thing it asks for is the list where I entered my x's, called the x values list, and the list where I entered my y values. I entered my x's into list 1, I entered my y's into list 2, I click calculate, and you'll notice that not only does it return the equation 7.5714x minus 9.666, it also gives me the r value, the correlation coefficient, and the r squared, which is called the coefficient of determination. In addition, it identifies the y-intercept and the slope. Now, before I graph, let me mention that there is a help available. You can go to the menu and click on Show Help, and that's available on all of the regressions. It gives you the formula that you should be looking for. It gives you a suggestion to enter the x's into list 1, the y's into list 2. It reminds you that both lists must be the same length, and that you should be using the linear regression when the plot of the data looks like a straight line. It also tells you that r is the correlation coefficient and the bounds on r. It must be a number between -1 and 1. Let me go ahead and go to the graph. You'll see the regression equation graph is in red. The raw data are these white scatter points. It gives me the equation here at the top. This is the line of best fit. It gives me the correlation coefficient, the coefficient of determination, the y-intercept, and the slope. So everything's here on one screen. So as I mentioned, I want to do a couple of regressions, so let me go back and run a quadratic regression. Again, there is a help available. I can go up to Show Help, and it's basically the same. There is a little bit of different. It tells me to enter the x's into list 1, the y's into list 2. It reminds me that the list must be the same length, and that we should be using the quadratic regression when the data looks like a parabola. So remember, that's the U shape. It also tells me that r squared is the coefficient of determination, and that it tells me how good my model is. It also tells me that the particular application function that I'm running does not force degree. And what that means is, even though you ask for a quadratic regression, if the application thinks that a better model is a straight line or a lower degree, it will return that lower degree. So if you had asked for, let's say, an x to the 4th regression, and the application found that an x to the 3rd model was actually better, it would return the x to the 3rd model. So after I click calculate, I see the equation here. It asks me where I want to place the results. I can put it anywhere I want. It shows me which ones are empty. I would go ahead and like to replace y1. I click graph, and you see now the curve fits this data much better. It's much closer to the scatter point now. It tells me the best equation right up here. We call this the least squares regression equation, and it gives me the coefficient of determination down here. And this ends your session on how to run a regression on raw data, part 1.